So now let us discuss about Coulomb's law. See what Coulomb has studied. He has studied about the forces experiencing by each charges. For example, you take two metallic spheres, metal sphere A and this is metal sphere B. So this is the central point. Okay, let us join this. So this is sphere A and this is sphere B. That means I am taking two bodies, body A and body B. They are in spherical shape. So from their centers we are having a distance, let it be r. R is the distance between the two charges. So what Coulomb says that, so there exists a definite amount of force present between the two spheres, two charged spheres. These are the two charged spheres. Either you can take both are positive charge or both are negative charge, or one is positive charge, another one is negative charge, no matter. So I will take you one example. So when you were in the lower classes, you might have seen the attractive property of magnets. So you were holding, say for example, I will take you to understand two magnets. Okay, so two magnets 500 gram, both are having 500 gram. You were holding at certain distance like this, 500 gram. Clear? This is one case. You are experiencing a attractive force. This is case 1. Second case, what I will do, I will take now 1 kg. This is separated with a distance of how much? You say 20 centimeter. Okay, we have taken 20 centimeter. Now here again I will take 20 centimeter distance, but I have taken 1 kg magnet. Keeping the distance same, but magnitude of magnet is increased. Understand carefully what I am trying to say you. So this is 500, that is 0.5 kg, you are holding the magnet at a distance of 20 centimeter. You are experiencing a force, you are experiencing an attractive force. That means it should be held with north and south poles. So then only you can feel force of attraction. When you are holding north or south, you cannot feel force of attraction. Are you clear? Okay, that is the condition. So in the second case, distance is same, but we have taken more magnitude of charge, 1 kg. And next in third case, 1.5 kg. And in fourth case, 2 kg. So for every increase, for every replacement, I cannot increase this directly 1 kg. Just I am replacing this 1 kg with 1.5 kg. I am replacing this with 2 kg, like that I can change. So what I meant to say is, you observe first one is 500 gram force F1, second F2 force is increased because magnitude of magnet mass is increased. Then third case again you have increased, but keeping the distance as same. When you are keeping the distance as same, then if you increase the magnitude of magnet, what will happen? Then force of attraction is increasing. So here also what Coulomb says, by increasing the magnitude of charge, first if you take 1 coulomb of charge, there exists some amount of force F1 you can say, and next again 2 coulomb of charge, again what will happen? You are not going to change the distance, you are changing the value of magnitude of charge. 1 coulomb, you are noting the force, that is F1 is the force exerting between them. And next 2 coulomb charge, force is F2, 3 coulomb, force is F3. So like that, as the magnitude of charge is going to increase, then what you are observing, the same phenomena which you have observed in where? In case of magnets. Are you clear? So now here also what we are trying to do, we are keeping the distance between the two charges. Only we are increasing the magnitude of charges. By increasing the magnitude of charge, what will happen? Yes, there is a increase in the amount of force present between them. Either it is attractive force or repulsive force. Attractive force or repulsive force depends on what? Yes, it depends on nature of charge. If it is a positive charge, then there will be repulsive force. If both are positive charge, repulsive force is there. and if both are negative charge, then also there will be a repulsive force, and if one is positive charge, another one is negative charge, then there will be a attractive force. Then he noted that the force of attraction between these two charges is directly depending on the product of magnitude of charges, product of magnitude of charges, product of magnitude of the charges. And now similarly in the previous case, by taking that 500 gram magnet, okay, this is 0.5 kg, 0.5 kg, you go on increasing the distance. You increase this with one more 20 plus 20, that is total 40 centimeter we have increased, like this. From the center to somewhere you have got a 40 centimeter total distance. Okay. So when you have increased the 40 centimeter distance, then what will happen now? What will happen? Can you see the same amount of force which is in the previous case when you are holding the magnet with a 20 centimeter with 500 gram each? No, absolutely it is decreasing the force. Similarly, what Coulomb says, he says that whenever the distance is increased, force is going to decrease. Force is going to decrease. So mathematically, he has estimated with a force is varying inversely as square of the distance. Square of the distance. By combining these two equations, okay, what we can write? F proportional to numerator Q1 Q2 divided by R square. If this is directly depending, then we are writing on numerator. If this is inversely depending, we are writing on denominator. Clear? So by using this mathematical statement, we can construct a statement. How? We can state the statement as the force of attraction or repulsion between any two point charges is directly proportional to product of magnitude of their charges and inversely proportional to square of the distance between them. I repeat, the force of attraction, this force may be either attractive force or repulsive force. It depends on what? Yes, it depends on nature of charge. Nature of charge. If both are, one is positive charge, Q1 is positive charge, another one is Q2 is negative charge, what will happen? Plus into minus, Q1 Q2. But we are taking magnitude here, the magnitude of force, either it is positive charge or negative charges. I want to take only magnitude of charge, not the direction. Okay. So the force of attraction or repulsion between any two point charges is directly proportional to product of magnitude of their charges and inversely proportional to square of the distance between them. Square of the distance between them. So to remove this proportionality sign, we will take a constant factor that is called 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. See, originally or initially we have placed these two charges in vacuum condition. In vacuum. So vacuum means it is absence of air. Vacuum means what? It is absence of air. In that vacuum, the vacuum value is epsilon naught. Epsilon naught is called absolute permittivity. Absolute permittivity. And its value is, you know, if you write its unit, epsilon naught is equal to 1 by 4 pi f Q1 Q2 divided by R square. So if you want to write the unit, just to bring it down, epsilon naught is equal to, this is what? Coulomb square, this is Newton, and this is meter square. Then what will happen? Its value 8.854 into 10 power, yes, 10 power minus 12. Minus 12. So Coulomb square per Newton meter square. So its value is 8.854 into 10 power minus 12 Coulomb square per Newton meter square. Are you clear? So now for calculation purpose, so this is called Coulomb force. F is equal to 1 divided by 4 pi epsilon naught, then Q1 Q2 divided by R square. So this 1 by 4 pi epsilon naught is nearly taken as 9 into 10 power 9. This is very important value. Okay. So in problems we use this one, 1 by 4 pi epsilon naught. Every time we are writing 9 into 10 power 9. Are you clear? So This is about what? Coulomb force. The direction of force, as I told you, this is the magnitude of charge, magnitude of force, and the direction of force is acting along the line joining between the two charges. So the direction of force is lying along the direction of line joining between the two charges. The direction of force is lies, or you can say direction of force is considered to be a line joining between the two charges. Are you clear? So this is the direction of force. Next, if you want to write this in vector form, we can write vector F is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square r cap. R cap is indicating, yes, R cap is indicating unit vector. Unit vector specifies the direction of force. Direction of force. Are you clear? Okay. So next we will discuss the different cases. What are the different cases? For example, you see, when I am talking about the two charges, let's say these two charges were placed in vacuum. These two charges were placed in vacuum. When it is placed in vacuum, what will happen? What is the force? What is the force of attraction between these two charges? Yes, for vacuum, the force of attraction becomes F is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square. You can call this equation number 1. Similarly, I will go for another case where two spheres are again separated with the same distance as that of first case in the vacuum, but in this case it is going to filled with some material, some insulating material. So that insulating material, we can call it is a dielectric constant. So this is called a dielectric constant. When this dielectric constant is introduced, dielectric constant. So these dielectric materials are insulating materials. Either it is mica sheet or it is a glass. Okay. Mica sheet or it is a glass. Any that non-conducting, I mean insulating materials you can take. Dielectric materials are insulating materials. So such a insulating materials, when it is placed between the two charges, when a dielectric material, either mica sheet or you can take any insulating material which is placed in between the two charged spheres, the dielectric constant is denoted as K. For example, so this dielectric constant, I will call this is the medium. Okay, so this is the medium, and medium is having a value epsilon. I am making you very clear. So these are the two spheres by name A and B. So in the first case, A and B, two spheres, there is no medium, absence of air, it is in vacuum. The force of attraction is maximum. F is equal to 1 by 4 pi epsilon q1 q2 divided by r square. I am taking second case where the two spheres are made up of what? In between the two spheres is made up of what? S, or you can say you are adding some insulating materials between the two spheres. Now the two spheres are filled with some materials, means what? That is having a medium. That medium value is epsilon. Now the new force in the medium is written as Fm. So Fm is indicating that force between these two charges when medium is introduced between them. So Fm is equal to 1 divided by 4 pi epsilon q1 q2 divided by r square. Are you clear? So now divide these two. What will happen here? F divided by Fm is equals to, what is this here? S q1 q2 divided by 4 pi epsilon naught, and this goes to numerator 4 pi epsilon r square divided by this q1 q2 comes to denominator, that you know very well, f divided by fm. I have taken this complete term and this goes to s multiplication, okay, because this division changes to multiplication. 4 pi get cancelled, okay. So here I forgot to write r square, this r square and r square get cancelled, q1 q2 get cancelled. What remains here? F divided by fm, f divided by fm. So what remains here? Epsilon divided by epsilon naught. This epsilon divided by epsilon naught is equal to k. It is denoted as k, where k is called as dielectric constant. What do you call that? Dielectric constant, or it is also called as relative permittivity. You can also write this as epsilon r is equal to epsilon divided by epsilon naught. This is also called relative permittivity. Relative permittivity. So now what we can write? Therefore, f divided by fm is equal to k, or if you want to write the medium force, this is f divided by m divided by k. This is a very important formula. So you can bring here denominator, you can transfer to RHS. So Fm is equal to F divided by K. The meaning is, as the dielectric constant is introduced between the medium, then force is going to decrease. If K value is increased, then what will happen? Yes, force between the two charges will be decreased. That means same two charges, one coulomb charge, when it is placed in vacuum, it is experiencing maximum electric force. When the same spheres is filled with what? A dielectric constant, or you can say a medium is filled between the two charges, or if we introduce a dielectric material between the two charges, then force is going to decrease. As we introduce the dielectric constant between the two charged spheres, then force of attraction or repulsion between the two charges is going to decrease. The new force is, either you can call it is F dash is equal to F by K, or you can call it is Fm is equal to F divided by K. Are you clear? So in next class we will discuss about the special cases. Are you clear? Okay.